So to introduce a cantilever, you can right click on any of these axes. Not right clicking, I can click on offset axis. I will move my cursor along this, but just like I was explaining the other day, even with the fact that I will hold on Control F2. If it is going down, it's negative, up positive, left negative, right positive. So if I'm taking it down, let's say a cantilever of 900, I will type minus 900 and I'll press enter. Axis ni after. Catch it? Okay. When I click on this axis now, I can do an offset. That's, for example, if from the architectural drawing there is a cantilever here, and let's assume that cantilever is 900, I will click on the axis and I will right click. Click on this axis and I will right click. I will click on offset axis. I will take my cursor down and I will press Ctrl F2. So minus. Downward is negative, upward positive, left negative, right positive. Minus 900 and I'll press enter.
That is the cantilever depth.
Yes, yes, that's the width of the cantilever.
The length of the cantilever.
900. So if I'm going to have a cantilever here, I can just insert my cantilever. Now, one is going to be a bit tricky. Not clicking slab. Not clicking slab. It brings out this menu. I will specify the thickness of that slab. Not specifying thickness in a slab dinner. For example, and let's say I select any of this and impose load. Now clicking, you see the slab has been inserted. But what if, again, if I try to click, you're selecting Gabadia, this entire area haka as a slab. Bazesh Gawa, you see, it's separating them. There is a way I can do it. I can delete this. Let's say I delete that slab. Then I will click on that slab again. This time around, you will see here a quick beam region. If I click on this drop down, you see axis region. You see peak axis. You see peak points. You see peak close slab edge. Peak axis region means the region na axis. This is the region of this axis. What that means is that I have an axis here, I have an axis here, I have an axis here, I also have an axis here. So it will stop here. This is another axis region. This is another axis region. So it is bounded by an axis. Beam regions mean is bounded by a beam. CSR now switching one onto beam, it will pick the entire space now because it's on beam region. So if I switch to axis region, it will pick the region na axis nikawa. Now what I need to do, if I use the axis region, I may still not get, but at this point here the axis region may work, but it depends on how I want the cantilever to be. And then so to have a drop beam here, and then it will separate the slab. This will now be a different panel from this one. Yes. But if I want the entire, let's say this one is okay, for example, then but this one now, Kagani, this is going to be a very small slab, is separating it, but this is not what I want. So if I want to represent this the right way, I can pick points. If I click on pick points, I will pick this as a point. I can click this as a point. I can click this as a point. Click this as a point. You see it has insert as a slab. So now I have two panels together. Is it making sense? So this is basically how to get your cantilever. If I switch this to a 3D now, you can see a cantilever there. But definitely this one will fail. As a gear number because it has been separated. So yeah, we can introduce a beam. We can introduce beam.
You can take it for complete length.
Okay, we'll put the beam number. The none.
Not even that you can
Around it, Gavada. Okay, around it. Okay.
At a peak.
So however we want it. But this is just the concept of how to get your cantilever. So you must play around with one beam region. So now there are some irregular shape that sometimes you may want to achieve. One that is not going to be easy for you to achieve. You have to use this tool called polyline.
You are taking it?
Yes, sir. So you can see something like this. Once I draw something like this, I can have a grid that can go around it. One grid axis then. Not clicking grid axis now. You can see this is 3 points. If I click here, I can click this point, click second point, and click my third point. I can insert a slab here. I will use axis region and insert a slab. So let me change this to tile vertical. You can see. So however the shape of your building looks like, you can achieve it. I don't know if it is making sense. Ko in sake wannan wurin dan na gan kaman mun bata. Yawa, I will take Ctrl Z. Take it back. Abun ya dan fara zafi. To achieve a curved slab or any shape of slab, I can achieve it. All I need to do is, we have a polyline tool, we have an arc tool, we have cycle as a tool. So a circular slab, no matter how the shape na slab you can do it. So if I want to have a curved slab, all I need to do is to use this arc tool. If I click on this arc now, let's say I want it from here to here. So if I know the radius of that arc, it's just for me to specify that radius, or I can draw. That's why it's important for you to always import from AutoCAD. It makes life easy for you. If you import from AutoCAD, you can easily trace it using your one using polyline or sorry, gradients. Using gradients, we can pick 2 points, 3 points arc. This is curve axis insertion. You can see it here, 3 points. So all you need to do is to select 3 points. This is my first point, this is my second point, and then this is my third point. Sorry, I think I didn't get that right. Okay, it has been inserted now. Should I take it again? this is the grid. You know, I was explaining you can use orthogonal axis, you can use grid. Orthogonal axis, it will come with 3 options. I will select one on curve axis insertion. If I select the curve axis insertion, you can see on that curve axis insertion is showing you 3 points. The first point, the end point, and then the midpoint. So all I need to do is to click on first point, click on my second point, and then drag to my midpoint. Okay, I think my one might be shigaba, but that is basically what you need to do. Click first, second, and then you click the last point, the midpoint. So now it's okay. Because I was saying yesterday, the only way you can insert a slab, you must have 2 axes that are intersecting each other. At the point of intersection, that is the only place you can insert any structural member. So we must have this axis touching this other axis. Have this grid here also touching this other grid here. So I will click on my slab tool and I will specify the thickness of that slab and the concrete cover and the dead load. It's just for me to select what type of dead load and select what type of life load. Then I will just come and insert. But you see, as I'm trying to insert, it's separating them. So I have to come back to this general and use the right insertion. So I can pick points or pick axis, man. When I'm using pick axis, man, it should work. We have, I think we have 2 axes here. We have 1 axis along this part. Sorry, I mean scattered. Or I can just pick a point. It's just to select a point, select another point, that didn't insert. You say what? Don't worry, I can manipulate it and stretch this line. So now, Yazuma, it should work. So if I click on this slab, if I use the axis region, Mayakamata Yashiga. So these 2 grid axis name as so you can manipulate it and model do your modeling however it comes. It's very, very simple.
So when you finish this sketch, then you allow it to calculate all the necessary details.
Exactly, because the modeling is the first thing you need to do first. So you must model it to look just like the way the architecture was given to you. But you know, Anang, we don't consider so many things the architects keep considering. All those doors, windows, the bar one modish. So this is how it's gonna look like. Cut a section. Okay, Aishi and Anang. This is how to bring a cross section. To cut a section, come to detail library, click on plan section. Okay, click in plan section. All you need to do is to click 2 points. She can anga section in after. Sannan kuma around this staircase area we can have a staircase, but you know, like as I was saying, this modeling staircase ananko is just for, but even in real sense, staircase is a complete entire independent structural member. So, but there is a way we can, somebody was asking of ramp. So the same way you can represent your staircase, and you know it comes with a slope, the same way you can do your ramp or whatever one that is going to slant. It's the same way.
Do you have them in the template there where we went for the staircase earlier on?
No. No, it's part of modeling.
Okay. The other time you
Okay, staircase one approach detail to design the staircase.
Okay, sorry.
This place sketch. Now we are just doing the modeling. We are just modeling the structure. So we should go on. So none is simple. All you need to do is you can use your polyline and draw. Okay, this is going up like this, but so one is a kasa. Finish. I thought I've drawn it one. Aha. So what we'll do now, we can insert, it's going to come in form of slabs in the curve. It's going to come in form of slab. So we can introduce our grids. We are gradually getting to the boring part. So we can insert our slab using pick points. I can pick on this point, pick on this point, pick this point. Okay. I'll click here because I need to stretch this. slab, points, pick here, pick here, pick here, pick here. I have a slab there. I will introduce another slab here. I'll pick here. No. Actually, no. One number, I have to stretch it because you must have an intersection. There you go. So let me rotate this one so that it can look. Let me hide all this one. Okay. That's what I'm supposed to hide. So this is what we have now. I will insert a slab here. Pick points. Point 1. This here. Slab. Pick points. 1. 2. Points. 3. Point 4. No, I don't think this thing is correct. Let me stretch it more.
Yes.
Let me stretch it out.
The upper one.
Pick axis. Let me start from here, Koi. 1. No, this is supposed to be it here. The axis is here, and then here, and then here, and then lastly here. I have a slab there. So you can see it from the 3D. Similarly, I will pick another 4 points. 1, 2, another slab. Huh? So what I'm going to do now, we need to pay close attention. This now, you know, your normal staircase, if you view it from the 3D view, the height is 3 meters, what? So this landing now can go, we'll take it down, maybe like maybe 1.5. 1.5.
In the middle,
we can take it.
Between the 3 meters.
Yes, sir. So if I right click, I will come to the property of this. And then the level now, I will take it to 1,500. Let's see. Okay, sorry. It has gone up instead of down. Property minus 1,500. So it has gone down. So this one too, I can take it to the level of minus 1,500 and I'll update it. So this one will slope down, this one will slope up. So this one too, I will take it minus 1,500. I'll update it. So there is a tool called plane definition. If I click on this, I will click on plane definition. If I click on plane definition, this is plane definition. This plane definition now is for me to pick points that I want to take down. So I will click for my point 1. It's just for me to select where I am taking down. Sorry. Set plane definition.
How you set it for the
another. Select members are hidden. Let me find a way around it. Sorry, I will have to rearrange it. Yeah, now. Plane definition cannot be found. Okay. plane is not inserting. I will have to troubleshoot and figure out the problem, but I will fix it. Okay. Sorry, I will fix it and may probably skip this part for now. I'll fix it. We'll do it. Because of time, we can. Because of time, I'll fix it. I'll fix it.
You have to treat it as inclined number.
Yes, sir. We are supposed to use a plane.
Can't you draw it from the 3D?
I can, but it won't be right. This is the right way to do it.
On the other way.
To use a plane definition.
The plane definition will allow you to
Yes.
slam the slab, isn't
Yes,
it?
yes, sir. This is the right way to do it.
And it makes sense. The plane will tell whether it's 45 degrees. Does it go on degrees or you just specify the angle?
Yes, the plane definition, all you do is to specify, you can specify, yes, where you are taking it to. It will take you there. It will follow. If I'm taking it up, I can specify and it will follow suit. So, but as regards to this, we've been able to achieve to a reasonable length. Except if you have some more questions as regards to this, we can trash that. But you know, this slab cannot just hang like this. Definitely, we will have to introduce a beam. So the software makes life way more easier for you. You can introduce a beam. You can introduce a beam, and you can introduce, well, this column and this column can take here. Then at this point we can introduce another beam. We can introduce a beam here. So you are basically just doing modeling. By the time you are done with the entire model, you can now analyze the structure and do the design. So however your model is coming, you can actually model it. However it's coming, the software can be able to design it for you. However it's coming, however it may come, it can design it for
The way
you.
it is now, even if you go to analysis and design, it will not.
Yes, it won't.
Not analyze it.
It won't. Because of the plane. But it will give you an error. You can decide to ignore it. You can decide to ignore it. It will give you an error, but you can decide to ignore the error and go on with it. Because because that plane definition, even if you get it right or not, Zebaka error. The plane definition must Zebaka error. It's like a warning telling you, Chewa, there is an incline. Yes, it's like a warning. So, but because Kekasa happened the Kaya, you can proceed. No, this one that is suspended is not right. It's just for us to introduce. We can introduce another beam. I can take this beam now down. I can take this beam down and introduce another beam. Yes, I can take this beam down. Similarly, it's just for you to select, go to the property. Nkazo property then is just for you to change the level. We have del Z, we have del ZI, del ZJ. So del zi now, I can take it minus 1,500. Shima del zj minus 1,500. So now clicking, I can click on updates. You can see the beam has gone down. I can delete the wall load that is there. So this part is very, very tricky, guys. Yeah. This part is very, very tricky.
What if you rotate it?
Like this.
Baby.
I can delete the wall load. Delete load. Yeah, take it. This is the most tricky part of the software. You can introduce a column anang. I know it's already becoming very boring.
No. More interesting.
Because one and I just this one like this. For you to practice it can take you a little time to get it right.
It happens when some of these softwares, even we have similar softwares, you do it, then it will tell you error.
Exactly.
It will be warning you.
That's right, sir.
So when you know the basic, you know what you are doing is correctly, then you allow it to go that way.
Exactly, sir. Exactly. So,
5. It's already 5. 4 minutes to 5. If you
Gotcha.
reach super, when you reach super,
you auto can do it.
Na Obama mu don canza riba ba na ofis ne sama tijani ne amma na magana za su anan bypass
AutoCAD what?
Usman
AutoCAD
Tijani,
move it?
Engineer Usman.
We should do AutoCAD.
Anan bypass amma za su magana za su na ofis
Are you AutoCAD moving? Okay.
na ce mun kaka ce mun gari ne can kawai ba can bane yanzu ne wanda ya ce an ya ko ba gwani ne ma explain ne ma ina mana bypass sai na Usman Tijani amma na magana a shi sorry I go
Okay, so they were suggesting among a lot of us Adam don't really have good insight on AutoCAD. That's what they are suggesting.
Why do I never see AutoCAD? AutoCAD? Baka san normal AutoCAD ba? That's serious.
I think I told you.
That's serious.
That which area number AutoCAD.
That's from the first principle. That is just like you are drawing board near AutoCAD. You know what I mean? Abin da za mu yi su within us ga Muhammad ya yi ga
Umar ma iya.
Umar ma ga
Dadi ma iya ba.
ga da mu ma iya
Ma iya.
zan
Sai ya ta ci
you
su.
know it ba especially ka you need to know it sosai ba you need to know it sosai
No, tunda you have background in ArchiCAD background, zaka gane da
shi AutoCAD ya kamata dama yanzu sai wannan da will do the training on their own.
Okay.
Yeah, sure. So that's the use training. Then it is from the AutoCAD you can import it into Abuna. It's really much easier. You propose your position of columns, your position of reinforced concrete wall, any other Abuna that you can so on the AutoCAD. Then shake it importing nasu zuwa Prota. Then kaman yadda ya faɗa nan your layers kaman na column should be on column only. Reinforced concrete wall should be only on reinforced concrete wall. Come on, axis, they should be only on axis. So when I'm importing nasu, so the 3D, all you need to do is to give them the height and abundance. They generate it automatically.
So it's very important.
So you must know AutoCAD. You must know AutoCAD. But there's no way you can. In fact, most of this computer have no money if you don't know AutoCAD from the first principle. Because AutoCAD machine from the first principle. Come on, you are drawing board, you are just telling you are drawing board. But if you don't know it, most of these things you must go back to AutoCAD and edit them. In most cases. Shi yasa ake sa wannan abin nan interface wani GFX.
Da zuma ya yi shi kan toma kai ka mai da shi AutoCAD
Da kuma GFX ba this is it.
Ya yi arrange din abubuwan sa.
So that means we must take it off as a we do it for once in a week or once in every 2 weeks same mission.
kuna side ma.
Yeah.
Ba ku
Za
da
su
wani
zauna.
abu.
Sai ku
Da
zauna
kuna
ku
gida
yi.
kawai ku
Sai
shiga.
ku zauna ku yi kayan ku.
Ku yi kayan.
Ko yanzu wayannan su prota din nan ma yukan za ku je ku yi ta zauna ku yi ta musu yadda ake yin sa. Wani ya ce ba haka ba, wani ya ce haka na ba haka ba.
Design ne ba ku taɓa yi kai ba.
Ne din.
AutoCAD muna dan idea a kai saboda mun yi shi a factory. AutoCAD ne. So
ai yanzu aka jima ka kai ba za ka iya ba. Shi kwamfuta shi da kansa yanzu aka koya maka yanzu wani abin da aka koma in the next 1 week an baka koma ya kai ba ba ka kai you can repeat
Akwai step ɗin kai musu
ai shi
gaba ɗaya.
yasa nake insisting akan cewa let him take it so that an ma ka samu wani abu you can see
Just
yasa nake insisting haka yake
So yanzu a shi presentation da za ku yi ma a shi
gobe ba wanda zai ba zai muna cewa gobe za a presentation da muna ce ba za a yi
zai dan ba da
ko a sake rikitin ake katin gobe
SketchUp ne
a wani SketchUp ne ke fara
a SketchUp ne za mu yi implementation.
an yi exhaustive SketchUp ne
Shuma ba yau.
Ba kai mu yi yawanci abubuwa ba ma.
setting wani setting da kan
Eh, an yi har an shi wancan abin nan ne mai
Kaga na mustiwa ya zama architect ai.
ba wanda aka ce na rufiya ba
Shi ne.
kai practice a gida ba kana follow up da practice Wai ya gawa koyo.
abin da stream ya faɗa musu ya yi yadda suka ce koya musu porota wai sai to ya koya musu
shi stream na ya yi porota ne
ya
okay
da akwai Orion amma an ka iya porota Orion may not be a problem kuma an ka iya Orion ma porota may not be a problem
amma shi Orion ne ya ko
shi na ji ko kuma sai Orion ko porota ne
shi ne da aka ce koya musu sai ce wai ba zai ki ba mu
Allah baka ji wai ce wai shi ne zai ce wai.
a waya koya musu
to yanzu yana da su suna nan mai hana su
what do we do tomorrow?
Yes, let's know the program.
Let's know the 2 hour amma gobe ɗaurin ma mutum na zaga ne abin da yake faruwa gari nan gobe ba da rage
vice president na gari gobe
kuma daga nan ya haka zan kuna da aure gobe ko?
Musu aluminium. Me aluminium din nan zaka san.
musu
Di kwale ko so ne. Akwai na wani da dan su. Mata da maza ya kai dubu.
Sama mu make that 12 or 2 da. 12 is good to go misala azara.
to sai ka bada assignment
Mu zo 2.
Okay.
ka bada assignment kar ka je ka kwanta wai an ce kaza sai lokaci kaza in kun je gida sai ku huta sai ku yi
Za mu fara zuwa ba.
Mu zo
ku
12.
ga musu wani stage wanda za su yi kuma ya zo sai ya presenta
Ba mu da fara misala. Dan ba ka wa muka ce da bayan
We can reproduce one and draw in Nigeria. Let's
ba su da zo da sabi.
approach da na SketchUp din shi ma na Prota da na SketchUp kawai ai shi
that's the assignment tomorrow when you come you show how the stage is used
su akwai da suka je sa yau ne?
za ku iya ba mu recording
Eh.
Gobe